So good morning. In this chapter, we're going to learn about principles and configuration of what we call the point-to-point protocol over Ethernet. In the previous chapter, we looked at PPP, which was used to govern the data link, or layer 2 connection between devices over the serial cable. So really, PPoE is when we are using the Ethernet cable. So that is what we want to look at. I'll read the foreword. The application of digital subscriber line technology relies strongly on the existing telephone infrastructure that is found in almost every household and office globally. Of course, not in Africa. With the continued development of newer DSL standards allowing rates of up to 100 Mbps, the application of DSL as a WAN technology for home and enterprise remains firmly valid. Traditional DSL connections were established over legacy ATM networks, asynchronous transfer mode networks. However, Ethernet has continued to emerge as the underlying technology on which many service providers establish their networks, and therefore knowledge of PPoE technologies remains valued for establishing DSL connectivity at the enterprise age, By the end of this chapter, you should be able to volunteer.
Describe the PPoE connection establishment process.
Yes.
And 2, configure a PPoE session.
Configure a PPoE session. Who is this?
Chris.
Yes? Chris. Great. Asante sana, Chris. So digital subscriber lines. With digital subscriber lines, let me just, with digital subscriber lines, data signals are carried over the copper telephone lines, also known as the local loop. Now, and that is why I said not in Africa. When the foreword made an assumption that in many homes and enterprises we had the telephone network. So a few years ago we had Telkom Kenya. I can't remember their name that time. I think it was Posta or something. They were under Posta, and we had telephone lines just like we have electricity lines on the road. So we had telephone lines which were actually terminating at only a few rich people's homes and in most enterprises. So that particular line, just like the power line, was coming up to your home. So now we can use the same line to interconnect you to the internet. We use your telephone line to interconnect you to the internet. So that is what we call local loop. And that is what the digital subscriber line is all about. Now, generally, that particular line that is interconnecting you to your telephone, they interconnect in a central place, which has what we call a digital subscriber line, access multiplexer, DSLAM. So that is a digital subscriber line access multiplexer. So you can think of this like when it comes to electricity lines, we always have a central place in every town where every line, I don't know what it's called, but we have a central place. Just a moment. Okay, so we have a central place within your town where all the lines are meeting, something like that. So that is where we have this particular transceiver, which is called the digital subscriber line access multiplexer. Now, this particular device actually is the one that uses either serial lines. It uses either serial lines or uses Ethernet cables to interconnect you to your ISP, So it can use serial cables using technologies such as ATM, or it can use Ethernet cables like fiber, Ethernet technology like fiber cables to interconnect you to your ISP. So from that central place, then now your ISP now is the one that will connect you to the internet or to your other remote sites. Now, that particular device that interconnects the digital subscriber line access multiplexer at the ISP site is known as a bus or a PPPoE server. So it's known as a PPPoE. So PPPoE, first of all, is point to point over Ethernet. Point to point over Ethernet. That is what PPPoE is. So I'm saying the bus is known as a PPPoE server, or it's also known as the bus, and the bus is what we call a broadband remote access server. A broadband remote access server. A broadband remote access server. So that is what interconnects you or connects the DSLAM with your ISP. Okay. So let's move on. So here we have most of the things that I've already told you about. So you have your enterprise, and in your enterprise you have your enterprise edge, which is your router. Now your router will connect to a DSLM modem. A modem is used for modulation and demodulation of signals. That is changing signals from one format to another. You see, in your enterprise network, you're using, for example, Ethernet cables. And now you want to change these particular signals so that they can be carried over the telephone lines. So for that purpose, you need a DLSM modulator, demodulator, a DSLM modem. Now, this DSLM modem, in your area, you have a central place that has this device called the digital subscriber line access multiplexer. Then that digital subscriber line as access multiplexer is owned by your ISP and is going to connect you to a PPPoE server or a bus, which is hosted at your ISP central location. Then now that PPPoE server is the one that is going to connect you to the internet. So the bus is actually what we call a PPPoE server, or the broadband remote access server. So that is actually the application of PPPoE in enterprises. It can be used to connect us to our ISP as an enterprise. Now, PPPoE uses several protocol packets in order to establish and maintain the connection. This is done over 2 stages. So we have generally 2 stages when it comes to PPPoE session establishment. The first one is called the discovery stage, and the last one is known as the session stage. So in the discovery stage, we are trying to create a session between your modem in your enterprise with the PPPoE server at your ISP's end. So to do that, we use these four packets. We use these 4 packets, what we call the PPPoE active discovery initiation packet, PPPoE active discovery offer packet. Then we also have the PPPoE active discovery request packet. And we also have the PPPoE active discovery session confirmation packet. The PPPoE active discovery session confirmation packet. So all this happens during the discovery stage. Now, after you've been able to form a session between your DSL modem and the PPPoE server, then you enter into the session stage, and that is the only time you can be able now to access your remote sites and the internet. Now, when you're done accessing the internet and the remote sites, you can also send what we call a PPPoE active discovery terminate packet. A PPPoE active discovery terminate packet in order to close the PPPoE session. So those are the 5 packet types that PPPoE uses. And this is one of the most examined parts of this particular course. So make sure you understand in the coming topics how each of these particular packets actually work. Now let's begin with the very first part of the discovery stage. So in the very first part of the discovery stage, your DSLM modem or your router is going to send a PADI, a PPPoE active discovery initiation packet. Now, the PADI is a broadcast. So why is it a broadcast? Because your ISP is going to have several PPPoE servers at their site. So for example, server A, B, C. So it's going to be a broadcast. And the reason as to why it's a broadcast is because different PPPoE servers might be offering different set of services. Different set of services. So that's why you make your PADI a broadcast. Now, when you're doing a PADI, several things to note is that the code for a PADI is this one here. It's in hexadecimal. So that's the code value for a PADI. And the other thing to note is that the session ID will be all zeros. So you've not set up a session yet, because after all, you're still in the discovery stage. You're still in the discovery stage. So that is the PADI. So don't forget that the PADI is a broadcast. And at the PADI stage, you do not have a session ID. So then we move on. Now, depending on the services that you've requested for, several servers that offer those services are going to reply with an offer, a PADO, PPPoE active discovery offer. So for example, in this particular case, RTA is receiving an offer from PPPoE server A and PPPoE server B. So it is important to note that server C here is not responding with an offer. Why? Because offers are returned to the sender by all servers that can service the received PADI packet. Again, at this particular point, the session field has not been set, and therefore it's all zeros. The code field that identifies an offer packet is actually 0x07. So that's the code field that identifies an offer packet. Okay. Then after your router receives, we are still, by the way, on the discovery stage. After your router receives offers from different servers, your router is going to reply with a request. So PPPoE active discovery request packet. Now the request packet is going to be a unicast packet directed to a particular server. So remember, we got offers from server A and server B. So we are going to choose either of them depending on what we call the AC name. We will choose a server based on two things, based on two parameters. Let me call this parameters. So the first one is what we call the AC name, or access concentrator. Concentrator name. So in this particular level, they have not explained how that is done, but just know that at this particular point. Then the next thing is the services offered by the PPPoE packet. So here we are choosing to get connected via server A. So I'm not sure whether RTA used the access concentrator name of that particular server. The access concentrator name is used to uniquely identify each PPPoE server in your ISP. So I don't know how they choose it, whether it's the name with the largest or the smallest value, something. There must be some protocol there. Then other than that, it can also choose depending on the services that are offered by that particular PPPoE packet that was replied by the server. So this time we're choosing to connect to server A. Again, at this point, we have not formed a session yet, and the session field will have all zeros. And for a PPPoE active discovery request packet, the number is actually 0x19. So that is the code field number that is used to identify that particular packet. Now, after server A receives the request, they are going to reply with a PPPoE active discovery session packet. PPPoE active discovery session packet will now set up a certain value, value for the session. So the session ID will be formed at this particular point. So the chosen server generates a unique PPPoE session ID in preparation for negotiation now of the PPP session. So after the PPPoE session is established, we now go ahead and negotiate and form a PPP session. So PPP, what we looked at in the previous chapter. The code field that is used to identify a packet, a PPPoE active discovery session packet is 0x65. Again, as you can see, the PPPoE active discovery session packet is a unicast. Okay, so this is what we were saying. So it is important to note that when you're using PPPoE, you'll have two stages of negotiation. The first stage will be the PPPoE negotiation. It will use those 4 packets in order to establish a session, and thereafter, the PPP negotiation we looked at in the previous chapter will ensue, starting with LSP negotiation, then authentication, then at the network phase, they are going to do NCP negotiation in order to establish network layer parameters that they need to use, like the IP address. So the next part of it is we now look at the packet size of the packet size negotiation when you are using PPPoE. Now, generally, we've been mentioning this the maximum receive MRU, maximum receive unit. We also have what we call the maximum transmission MTU unit, and generally the maximum payload size for Ethernet is actually 1500 bytes. 1500 bytes. So what does that mean? It means that frames on Ethernet cannot be bigger than 1500 bytes. It needs to be 1500 or below. Now, generally, when you use PPPoE, as we've seen, you must also use PPP. So that after PPPoE negotiation, you go into PPP negotiation. As you can see, this takes up a total of how many bytes? 8 bytes. It takes up a total of 8 bytes, and therefore the space that is left out of that for the other data is 1500 minus 8, which is equals to, I think, 1492. 1492. And therefore, anytime you are using PPPoE, the MTU must support a value not larger than 1492, so that we can at least leave the 8 bytes, for PPP and PPPoE headers. Now, once your router is done accessing the remote sites or the internet, it can terminate the session, the PPPoE session, using the PPPoE active discovery terminate packet. So again, this is a unicast packet that will be destined to the particular server who offered you the connection to your remote site or the internet. So this particular packet is used to notify of the termination of a PPPoE session. Used to notify of the termination of a PPPoE session. Now, two things. When you're sending the PPPoE active discovery terminate packet, you must send your session ID. Your session ID, so that the PPPoE server can be able to know which PPPoE session it's actually going to terminate. So you must send your session ID. Now, generally, the code field value for a terminate packet is 0xA7. This isn't supposed to be times. Like that. So that is the terminate. So now let's see, how do we configure PPPoE? You're going to do this in the lab. But I need to explain some of the commands at this particular point. So you have RTA, you have RTB. So Huawei routers can act as a PPPoE client or a PPPoE server. So let's begin with configuring the client. So we begin by configuring what we call a dialer interface. a dialer interface. The dialer interface is configured by, first of all, creating a dialer rule. The dialer rule enables us to access the dialer rule view, which is used to help us to set the conditions for initiating the PPPoE connection. So once we enter dialer rule, we can be able to now set a condition like we want to be able to permit any IP packets on this particular dialer interface. So after that, we go ahead and create a dialer interface. This is just a virtual interface, just like we've created loopback interfaces, which is also a virtual interface. So we create a dialer interface like that. So here we are creating interface dialer 1. So it will get us into that view. And now from this dialer 1 interface, we can be able to do a number of things. For example, we can be able to specify the username. The username that can be used for this particular PPPoE client. So here it is enterprise, like that. Then we also are supposed to create a dialer group and a dialer bundle. The dialer bundle is used to bind the physical interface with the dialer interface that we've just created. We're going to see how that is done in the next slide, how the dialer bundle is used to bind this dialer interface that we've created with a physical interface. So after that, we need to create PPP authentication parameters. So here we are simply creating the username and the password using those two commands. And finally, we configure the IP address so that it can be automatically negotiated for this dialer interface. So using the command IP address, PPP-negotiate, IP address, PPP negotiate. So now let's look at the PPPoE session binding. That is what I talked about in the previous slide when I talked about the dialer bundle rule. So on this particular interface on the client, we want to bind this with the dialer interface we just created. So in RTA, we go into that physical interface. Then we use the command PPPoE client, dial bundle number 1. So the dialer bundle that we just created. Then we enter the command on demand. So here we've done two things. Number one, we've bind this physical interface with the virtual interface dialer 1 that we just created, and we are saying that it should be on demand. The connection to the PPPoE server should be on demand. Only when a client maybe needs to connect to a remote site or the internet. So it should be on demand. So it should not be up all the time. Then after that, we quit. Then in order for this to work, in order for a PPPoE session to work, you need to configure either a static or a dynamic route. A static or a dynamic route. This time we are using the default. Static route. So we are simply telling the router that if you need to go to any network, deliver that packet to this interface, dialer 1. So that's why we are using the any cast address 0.0.0 with the mask of 0. So IP route static 0.0.0 space 0, then dialer 1. So that is what we are simply telling the router. So a binding is performed for the PPPoE session with the dialer bundle command, and associated with the PPPoE1 interface. So that particular interface, G001, that is connecting us to the wide area network. So after you've been able to do that, we can be able to validate some of the, what we've just configured by using the command display interface dialer1. So we can see things like the current state as being up. So this is the physical state of this virtual interface dialer1. So it can be down if the physical interface we have bind it to is down. Then we have things like the line protocol, current state. So if the LCP negotiation has gone on well, if all the negotiation, PPPoE negotiation, PPP negotiation has gone on well, and the status of this particular link is actually good, then the status will be up. If we have any issue on the protocols that are involved in PPP or PPPoE, then the status of this dialer bundle will be down. Other things you can see is the state of LCP. You know that when the state is opened, it means the link has been established. IPCP, when IPCP state is opened, it means you've already acquired an IP address. So you got a configure acknowledgement. So those are some of the things that you can confirm from that. The other thing you can validate when it comes to PPPoE is the state of the PPPoE. So you can use the command display PPPoE client, display PPPoE client session summary, session summary. So you're going to get some details like the dialer number, the group that it's in, the physical interface that it has been binded with, the MAC address of that physical interface, the server MAC address, but most importantly, the state. So the state can be idle or up. The state can be idle or up. So generally, look here, the PPPoE client session status can be determined as either idle. When is it determined as idle? It is determined as idle at the discovery stage. Now, once you've formed the session and you have a session ID, then the status of the PPPoE client session will change to up. So that is the difference. The status will change to up after the session has been established and you have a session ID. Otherwise, during this discovery stage, the PPPoE session will be on the idle state. So in the enterprise network, generally your router always acts as a boundary between your what we call internal private network and what we call here the external public network. Now the difference between these two kind of networks is in your internal private network, you actually use private IP addresses in your internal private network. On the other hand, in order for packets to be routed in the external public network, they must use the public IP address. They must use the public IP addresses. So for that purpose, at your boundary, that is at your router, which is acting as the PPPoE client, it needs to be able to do what we call address translation. Address translation. So it's actually called NATing, or network address translation. So just creating an association between private addresses and public addresses, so that when you're going out, we give you a public address. When you're coming in, we swap that packet with a private IP address. So there's an entire topic about NATing that we are going to learn in the coming chapters. So don't worry about that right now, but just understand that for you to use PPPoE, you must also configure NATing at your PPPoE client, which is actually your router. So that is it about point-to-point protocol over Ethernet. So let me choose two people to lead us in discussing these two questions. Bethwell, are you there? Then Lynn, you can help us with the next one.
It's necessary to reduce the MTU/MRU size of PPPoE packet. Okay, I think it is so that the size of the packet does not exceed the payload. Is it the maximum?
The maximum payload size, eh?
Size, yes.
Which is set at
1490. Is it 1500 minus 8? It was 1490.
Yeah, but the maximum payload size on Ethernet networks is
1500.
1500. Thank you very much. So when you're using PPPoE, it should not go beyond 1492. Thank you very much. Lynn, go ahead. Thank you, Bethel.
Let someone else answer that, please.
Okay, just read the question.
What is the purpose of the dialer bundle command when establishing the PPP over Ethernet connection?
Okay, someone? What is the purpose of the dialer bundle command?
The dialer bundle command binds the physical interface with the virtual interface.
Yeah, very true, Joshua. The physical interface and the dialer interface, which is actually a virtual interface. Asante sana, Joshua. Asanteni sana. That is it. Asanteni sana.